If you're new here, welcome to the channel. And if you are a returning viewer, welcome back. It's no secret that we've seen an explosion in innovation across the large language model ecosystem. It can be hard for anyone to keep track of all of this innovation. That's why I've put this video together. I want to completely demystify for you the aspects of the large language model ecosystem. If you've ever had questions like, what is Hugging Face and how should I use it? Or if you don't know what an inference framework is, or if you're curious about developing applications on top of open source large language models, this is the video for you. By the end of this video, you're going to be much more familiar with the large language model ecosystem. You won't be distracted by all of the latest innovations that come to you, but you'll be able to pick the right innovations to focus on for the app you're trying to develop or the thing that you're trying to do. If you find this content useful, remember to subscribe to the channel, like the content, share it, and post your comments in the comment section for this video. All right, let's talk in a little bit more detail about what we're going to cover in this video. Let's do a quick run through of the components of the LLM ecosystem that we're going to explore. The first one, and I guess most obvious, is LLMs themselves. So we'll talk a little bit about LLMs. We'll give a high-level introduction, and we'll go beyond the hype a little bit so you understand what LLMs actually are under the hood. The next thing is the infrastructure. So without the infrastructure, we cannot run or utilize LLMs. So we'll go into a bit about the infrastructure and why it's important. Next is Hugging Face. Now, there's a lot of questions around Hugging Face and what it actually is and how to use it, how to deploy Hugging Face models. We'll talk a little bit about Hugging Face, and hopefully that should clear some of that confusion up. After that, we'll talk about proprietary LLM development platforms. So these are things like OpenAI or Claude that you might have already had some experience with. Next, we'll move on to inference frameworks. Inference frameworks are really important and serve a key role in app development for large language models. We'll move on to the app development frameworks. So these are things like LangChain and Llama Index and the purpose they serve in this whole ecosystem. Last but not least, we'll explore front ends. We'll see the importance of front ends when it comes to demoing your applications to clients or building applications that users can interface with. There will be a technical blog accompanying this video. So those that are interested, you can read that technical blog and it will be linked in the description to this video as soon as it is published on Medium. All right, so it's worth talking a little bit about what large language models actually are. So this isn't going to be an in-depth mathematical explanation of what they are. I'm just going to talk conceptually here. And what I aim to do is try and paint a picture in your head that I hope will give you a better understanding of the rest of the components of the large language model ecosystem. So there's a lot of misconceptions about large language models. They're almost kind of treated as this mysterious thing that has sentience. And you can kind of tell in the way that people prompts them and the techniques that have come out for prompt engineering. I think that going forward, it would help you a lot to think about large language models as mathematical functions. Now, if you remember your math back in the day from school, you'll remember that a mathematical function is simply just something that takes an input and then does something to that input. So there's some mathematical manipulations like additions, maybe some multiplications, and then returns an output. And that's all we're doing with large language models. The difference here with this type of mathematical function, though, is that instead of just writing it out like we did when we were writing math in school, the mathematical function is learned from data. And then the other part to it is that this particular mathematical function has billions of parameters. So you've got large language models, the smallest of which have around 1 billion parameters. And some of the larger ones that we have seen can have hundreds of billions of parameters. In fact, it's rumored that GPT-4, the engine behind ChatGPT, has over 1 trillion parameters. So it would help to think about large language models as mathematical functions rather than these kind of sentient beings that are capable of creative thinking. Now that we understand large language models as mathematical functions, let's talk a little bit about how we actually get to these functions. How do we actually come to these functions? So I mentioned previously that these functions are learned from data, but what does that actually mean? In general, what you have is a corpus of text, and it's usually scraped from the internet. This is what makes up the data itself. So this text has billions of lines, billions of sentences put together in this massive corpus of text. What we're doing is we are taking this mathematical function and we're assigning it a task of trying to predict the next word in sentences that we take from that corpus of text. So in assigning it this task, we can algorithmically update the parameters in this mathematical function. And those updates are done on the basis of moving the model or moving the function in the direction of predicting the next word in a sentence more precisely or more accurately. We do this over and over again until we reach a point where that model is as good as it's going to get at predicting the next word in a sentence. At that point, we have our parameters in our mathematical function. And from then on, we can feed that function with a sentence, and then it will continue to generate the next words in the sentence as it sees fit. This is the basis of a large language model. So an interesting fact for you is that GPT, as in ChatGPT, GPT stands for Generative Pre-trained Transformer. So the generative part refers to the model generating text. The pre-trained part refers to the data training process that I've just talked about. And the transformer is the type of mathematical function that we're dealing with. So we have our definition of large language models as mathematical functions that have been learned from data. And they've been learned in such a way that they are proficient in predicting the next word in a sentence. And we'll give that mathematical function a special name. So we'll call it a pre-trained large language model. What's amazing about this pre-trained large language model is it's essentially done a lot of heavy lifting already. We've trained it on such an enormous corpus of text that it has picked up grammatical patterns and language patterns within that text that helps it generate responses to our queries. And that capability is enhanced the better it is at predicting the next word in a sentence. So that's what we'll call it. It's the pre-trained model, or sometimes you might have heard it referred to as a foundation model. Now, the foundation model isn't useful in and of itself. There still needs to be some further refinement of that foundation model for it to be useful in applications. We call this process fine-tuning. So we can fine-tune our pre-trained large language model to do a variety of things. One of those might be to actually follow instructions. And that's what you'll see when you're using a lot of the chat-based models. These models are pre-trained large language models that have been fine-tuned to follow instructions like answer your questions or have a conversation with you. Just like pre-training, fine-tuning is taking that mathematical function and feeding it data that mimics the type of activity that we want the function to perform. So whether that is having a conversation with you or whether that is following instructions or doing question and answer, we provide it data that mimics that activity. The mathematical function is once again adjusted via training, and we adjust those parameters in that mathematical function such that it becomes proficient at doing the activity that we want it to do. So that's fine-tuning in a nutshell. So by the end of it, we have this mathematical function that is able to follow the instructions we give it or to perform a task that we want it to perform. So holding the idea that large language models are mathematical functions, let's understand what you're actually doing when you are querying a large language model. So when you ask ChatGPT to return an answer for you, what you've actually done is you've triggered numerous mathematical operations within that model. And remember, the models have billions or sometimes trillions of parameters. So this could be trillions of mathematical operations that are undertaken to give you the response to your query. This process is what we call inferencing a large language model. So if you've ever used ChatGPT, you have run inference over a large language model. When you are fine-tuning a large language model, you're also having to update potentially billions of parameters. There are techniques which mean that you only update a subset of those parameters, but I'm not going to go into those specifically now. But you are having to update those parameters in the mathematical function. Both of these activities, both fine-tuning and inferencing, require specialized hardware to do. So this specialized hardware is a core component of the ecosystem for large language models. And we'll talk about that in more detail later on in this video. Okay, so let's talk a little bit about how we get access to large language models. There are two main routes for accessing large language models. So the first way is to use a proprietary service. So some of you might already be familiar with this, and that is when you use a service like OpenAI's API, or when you use something like Claude 2, for example. What you have there is a model that has been trained in-house by a company, and they give you access to that model via the API. So there's a lot of engineering that goes on behind that API to make the model suitable for your purposes. But you cannot get access to the parameters or the function file or the weights of the model itself. So those are all the same thing: parameters, function files, weights. You can't get access to any of that stuff. That is proprietary to the company that trained that large language model. The second way to get access to large language models is to use the open source platforms that are available to you. And here you can download the weights or the actual function. You can have those files physically, And sometimes you can even get access to the data used to train that large language model. So those are the two ways in which you can access large language models. Let's talk a little bit about why one would choose to use an open source model or a proprietary model. So there's two things here, really. There's two main reasons why you would choose to go for the open source model over the proprietary model, let's say. The open source model allows you to have full ownership of that model. So you don't have to worry about the politics of the organization that is serving the model to you. So an example of this would be what happened with OpenAI at the end of 2023, where we were all unsure whether the company was going to collapse or not. Imagine if you were a business developing a large language model powered application off the back of OpenAI. That would have been a very uncertain time for you. You also don't have to worry about model updates messing up your applications downstream. You have full and total ownership of the model, and you can do as you please with it. You can fine tune it in any way you want, and you know that nothing external to your environment is going to change that model. The other aspect of using open source large language models is that you might wish to use sensitive data, or you might have data privacy as one of your most pertinent concerns. Because of this, you may not wish to send your data to a provider of a proprietary large language model. And that's when you would opt for the open source option. So we've discussed the advantages of open source models, but what about proprietary models? Now, there are some advantages of using proprietary models, obviously. The first one to think about is that the proprietary models right now are the best performing models. If you look at any of the LLM leaderboards, they are topped by the proprietary models. I think at the time of recording this video, the top performing model is actually GPT-4 Turbo, which scores top across most metrics on LLM leaderboards. The other thing about proprietary services is that you do not have to worry about the infrastructure. And I'm going to get onto a bit more detail about the infrastructure in the next section to this video. But worrying about infrastructure is one of the biggest headaches around large language models. When you're using proprietary services, this is all handled for you by the service provider. You simply call the API and you get the model as a service behind that API. This convenience has actually led many people to build startups on the basis of just calling something like the OpenAI API. It's really easy to get proof of concepts going, and it's really easy to build products quickly by developing on top of proprietary APIs. Okay, so now's a good time to talk a little bit about the infrastructure requirements for large language models. So we've established that large language models are just mathematical functions. And we've also established that when we are inferencing a large language model, we need to perform sometimes billions of mathematical operations to generate some kind of text as the output. It turns out there's specialized infrastructure that we need to do this. So the specialized hardware component that we're talking about here is a GPU. And if you've been paying attention to any financial markets, you might have noticed that the NVIDIA stock price has skyrocketed over, say, the last 18 months or so. The reason for this is because NVIDIA is actually one of the largest manufacturers of this type of GPU that is required for large language models to operate. The reason that GPUs are so useful for processing with large language models is because of their ability to perform those mathematical operations in parallel. Performing these operations in parallel makes them more efficient. The type of GPUs that you need to run the processing for large language models is not necessarily easy to come by. And it's likely that if you're watching this on a laptop, your GPU within your laptop is not suitable to process these operations. That's where platforms and service providers come in. So the large language model ecosystem is currently being supported by service providers such as Rampod or UBOps, or even the cloud services that you might be familiar with like AWS, GCP, or Azure. Here you can rent GPUs, often on an hourly basis, and you can rent them at the appropriate size required for the type of large language model that you're using. These GPU service providers that I've mentioned also provide something else. So if you're developing applications at scale, you also want the infrastructure to be scalable, which means that you'll be able to scale up the number of GPUs you're using and the model deployments on those GPUs based on the amount of demand you have for your application. So imagine you have a chatbot application that is serving customers worldwide. You'll need an infrastructure that can scale to meet the demands of that. And these large language model GPU providers give you that in the form of serverless computing. So everything I've mentioned about the infrastructure requirements for large language models really is applicable only to open source large language models. Open source large language models don't come prepackaged on top of infrastructure out of the box like it would do if you are using the proprietary services. You really need to think about how you're deploying those open source large language models, and you need to think about the service provider that you're wanting to use to deploy those open source large language models. So that's it for the infrastructure part of the large language model ecosystem. Hopefully you can see how important this is to actually getting your models to work and later on developing applications on top of those models. So stay tuned, because next we're going to talk about Hugging Face and the importance of Hugging Face as a one-stop shop for everything large language models. All right, so let's explore Hugging Face a little bit. So I introduced Hugging Face briefly in the last section. And what I mentioned is that Hugging Face is essentially a one-stop shop for everything large language models. This is true, and I can't think of another platform that is more useful than Hugging Face if you are developing on top of open source large language models. So if you visited the Hugging Face website before, you might have been overwhelmed with the range of things available to you. My intention here is to bring some clarity to the Hugging Face platform and also give you an idea of where it fits in this vast large language model ecosystem. First and foremost, you have models available to you. So we're currently on the models tab now. And what you have on Hugging Face is actually not just large language models. You do also have computer vision models, multimodal models. You have your natural language processing models, and you have some traditional tabular machine learning models here too, reinforcement learning and robotics. We are focusing on large language models in this video, so everything else talking from this point will be in reference to services available to you for large language models. So there are thousands of models available to you, and it can be very tough to decide which ones to use. What I would say is primarily there are some models that are more performant than others. Also, of these thousands of models, Hugging Face is an open platform, so it does allow users to just contribute models that they have fine-tuned. But what you'll find, especially with the large language models, is that most of the fine-tuned models are just based on foundational models that are contributed by large organizations. And you'll see this because you'll hear about a model release from someone like Mistral AI, for example. And if we are to go to, if we type in Mistral, what you will see, if I just get that right. So if we type in Mistral, what you actually see is there are the original foundation models from Mistral. So this is the foundation model for the 7 billion parameter version of Mistral. But then people have actually fine-tuned and developed on top of this foundation model. So you can see here, there's an example of somebody fine-tuning and developing on top of Mistral. And there are thousands of examples of this. So when you realize that that's what's happening, it becomes a bit easier to select a model. Hugging Face also provides you with some services to help you choose the appropriate model. So there are actually Hugging Face leaderboards, and I'll navigate to one of those now. So what you should see on screen here is under the Hugging Face spaces, and we'll talk a little bit about Hugging Face spaces in a second, but let's talk about leaderboards first. There are different leaderboards here, and the purpose of these leaderboards is to actually give you some idea of how these LLMs perform against one another. So let's go into the Open LLM leaderboard first of all, and let's see what that is all about. So what we have here are all of the LLMs that are hosted on Hugging Face, and we can actually see how they perform against each other based on these standard benchmarks. So you can see the benchmarks across here, and there's a score. You're able to rank by the different scores that might be important to you. But essentially, we can filter using this dashboard. We can filter and decide what types of models we're going to look at. So if we're only interested in the 7 billion parameter models, for example, we can select these as a filter, and then our leaderboard only compares across the 7 billion parameter models. So this functionality does make it a lot easier to navigate Hugging Face and to decide which open source model you're wanting to use if you do decide to develop with open source models. There is also a chatbot arena, and I'll go to the chatbot arena to give you an idea of what that looks like. So if we go back to the leaderboards, and you can see the chatbot arena. So if you're developing chatbots, specifically, you'll want to pay close attention to the chatbot arena because it gives you an idea of how these large language models perform as chatbots. And that's not necessarily the same thing as scoring them on those benchmarks. This is a very different score, and it's kind of generated from the community too. So people use these chatbots and rate them against each other. And that's how you decide which chatbot is topping this leaderboard. Okay, so let's imagine that we want to develop a chatbot and we want to build on top of an open source model. So we're looking at the chatbot leaderboard, and we can see that the top performing open source model is actually Mixtral. And you can see this here because it's the one without the proprietary license. So we can navigate to that model on Hugging Face simply by going back to the main Hugging Face page. So if I do it like this, clicking on spaces, and then we can go to Mixtral, and we can see all the models available for Mixtral. So here we go. This is what we're after. We're after the Mixtral 8x7 instruct from Mistral AI. What's great about Hugging Face is it provides this model card for you, and the model card will give you all of the details you need about the model. So it'll tell you a little bit about the model's architecture. So here it's telling us that it is a pre-trained generative sparse mixture of experts model. It tells us a little bit about the performance. There's also links to blog posts here. It tells us about the different types of infrastructure that the model can work with. Also gives us the prompt template, and I've got a separate video on building chatbots that tells you why the prompt template is important, and tells us how to run the model using the Hugging Face API. So this model card is really, really useful, and it's something that helps you work with your open source models. So the other thing to bear in mind here is that Hugging Face actually gives you the ability to download the model files themselves. So we can see this by navigating to files and versions. And what you can see here is the actual model files. So what you see here where it says model 01 of 19 is actually a file that contains the model weights. And there's 19 of these files because we're dealing with quite a large model here. So you can download all of these onto your own computer, and you have those as your own. They're yours. Nobody can change them. They can't be adapted. So if you wanted to keep a repository locally of models files that you want to use to build large language model based applications, you can do that by visiting the Hugging Face repo for that open source model and downloading the model files or the model weights yourself. And everything here is what you require to actually be able to run and execute that model. Now, remember that I said that you can't just execute models on standard laptops, right? You're going to have to actually host this on a specialized GPU to be able to execute it. But you can store these model files anywhere as long as you have the space, the storage space required to store all of the files associated with the model. The other useful thing about Hugging Face is that it provides the license to the model. So here for Mixtral, we can see that there is an Apache 2 license associated with this model, which means that it can be used for commercial purposes. Now, it's important to note that not all models on Hugging Face can be used for commercial purposes. And where this isn't the case, there's usually a license provided that tells you the terms of use for that model. And that is it. So the model card, you can also detect the amount of downloads that the model's had. So it gives you an idea of the popularity of that model. So you can see which models are trending and which ones people are tending to use. Just all in all, it's a really useful way of being able to work with open source models. Okay, next, there is actually a lot more to Hugging Face, and for brevity, I've kept it short for this video, but I have mentioned some of the other services available to you on Hugging Face in the technical blog, which is linked in the description to this video. So please be sure to check that out if you're interested in learning more about Hugging Face and what services they have to help you develop your large language model-based applications. All right, so we have spent a little bit of time exploring some of the aspects of open source LLMs, specifically on Hugging Face. Let's divert our attention back to proprietary LLMs. So we'll focus our attention on the OpenAI platform. Some of you might have already visited OpenAI to use ChatGPT, but for the platform, we'll be exploring the API behind ChatGPT. So let's get into it. You can visit the OpenAI website and go to login as you usually would. From here, you'll be presented the option to navigate to the API. Now, I'm not going to go into too much detail about the OpenAI API, and that's because there is extensive documentation on their website, and I implore you to explore this for yourself. What I'd like to show you, though, in contrast to Hugging Face, is that there are models available on this API, but you cannot download these models. They are behind the API. They very much belong to OpenAI. You can use them as a service from the API endpoint, but you can't download them. So this is a list of all of the models available. And similarly to Hugging Face, you have different types of models. So we have our large language models at the top here. And the state of the art right now is GPT-4 and GPT-4 Turbo. You have GPT 3.5 Turbo, DALL-E, which is the image generation model. We have a text-to-speech model. We have Whisper, which converts audio into text. We have embeddings, and this is used for things like similarity search. And we have some moderation and GPT-based models, and we have some deprecated models that were earlier iterations of the models that OpenAI produced. So you can see here, OpenAI does give you some understanding of the capabilities of these models. So we have things like context windows. It even tells you how up-to-date the training data is. So I would implore you to check out OpenAI's API, see if you can start developing some of your own applications based on the API. As of today, I would still say it's one of the easiest ways to get up and running in terms of developing large language model-based applications. I think open source is the future. However, it is easy for somebody starting up just to go onto OpenAI, sign up for an account, and plug in the API endpoint into one of the development frameworks that we're going to talk about a bit later in this video, and start building your applications. The whole idea behind this is to make it easy to get up and running, and they have a lot of things to facilitate this on the development platform itself. So as well as giving you some information about the models, there are tutorials on here. You also have the assistants, which do a lot of the engineering for you when it comes to building more complex chat applications. So I'm actually working with a client that has built a hotel concierge bot on top of the assistance API. And that allowed them to get up and running quickly and test their idea in the field. Okay. And we have briefly covered the proprietary large language model based services. Let's take a step back and look once again at open source large language models and how we can utilize these to develop applications. There's a key component that we're yet to cover, and this is the inference server. Inference servers are really important across two dimensions. The first one is efficiency. One of my favorite inference servers via LLM provides a really efficient way to run inference over large language models. And if you recall, inference on a large language model is simply when we send a request to the model or send a query to the model to generate some kind of output. So when you're talking to ChatGPT, for example, you're running inference. If you're using an open source model, you actually need an inference server to facilitate this. The way I like to think about it is that if an LLM is like a jet, the inference server is actually the runway. This is what actually allows you to facilitate the inference across the large language model. So VLLM is really good because it uses something called paged attention to make sure that that inference across the large language model is done efficiently and maximizes the throughput across that large language model. This becomes really important when you're deploying open source models at scale. You want to do this as efficiently as possible to reduce the infrastructure costs that you will have in deploying those models. The second aspect to inference servers is interoperability. So this is really important because when we look at the app development frameworks, and we'll get into those in more detail in the next section, we have to understand that a lot of these app development frameworks were built around the OpenAI API. Because of this, a lot of builders in the AI engineering community initially struggled to use the open source LLMs with the existing app development frameworks. So things like LangChain, Haystack, for example. Here's where the inference servers come in. And this is also why VLLM is one of my favorites. VLLM has actually managed to find a way to create an endpoint that mimics the OpenAI API. So essentially what you get is the ability to deploy an open source model behind an endpoint that looks like the OpenAI API. From there, you can just take this endpoint and slot it into any of your app development frameworks, and it acts as a replacement for your OpenAI API. So you can do plug and play essentially with an open source model, just like you would do with the OpenAI proprietary LLM that you use. I actually have a video showing you how you can do this with the Mixtron model. I'll link it to the description of this video. So if you're curious, give that a watch. Let's briefly cover the app development frameworks. The first thing to note is that your app development framework actually doesn't provide you with any large language model. Instead, what they do is provide you with a suite of tools and functions that you can use to turn your large language model into something useful. If we take Haystack as an example, the chat engine is one of those wrappers that it provides you with. And you can plug your large language model into the chat engine, and you have essentially created a chatbot. There are other tools available for you. So there are tools to turn your large language model into an agent that has access to web search, for example. These app development frameworks are really useful, and a lot of them are still developing rapidly. So you'll see that Haystack 2.0 is being developed. LangChain made a lot of significant changes to its API in the last couple of months too. And also AutoGen is evolving and producing new ways to work with their agents. So because of the rapid development in these large language model app development frameworks, I would not just put all of your eggs in one basket at this stage. I would try all of them. Try to see if you can develop a chatbot across Llama Index, LangChain, Haystack, and even AutoGen. See what works best for you. What you'll find is that there are commonalities across all of these frameworks, and you'll get the idea behind what they're trying to do. I think they are all trying to achieve the same thing or similar things, but they just approach them slightly differently with slightly different levels of abstraction. If you're keen to get your hands dirty in developing large language model-based applications, I have created a course for you, and the course is linked in the description to this video. You'll get hands-on with Llama Index, and you'll learn how to build your first RAG application. So this is retrieval augmented generation. You can retrieve some text from Wikipedia and use it to answer questions. It also comes with a front end, and it will be a good project for anyone stepping into the AI engineering field. Be sure to sign up to the course if you're interested. So last but not least, the final part of the LLM ecosystem that I want to talk about is the front ends. Now, front ends for LLMs tend to be in the form of chatbots. And listen, I know that we have things like GitHub Copilot that isn't really a chatbot. It's more like text completion, but that fits directly into your VS Code ID. But for the most part, the majority of front ends that we see are chatbots. So I've seen two routes that people kind of take around this. The first route is to build a Streamlit application. So Streamlit is a Python package that allows you to build a front end easily. So it's composable. You just declare the bits of the front end that you want to build, and it is quite straightforward and easy to use. But the one I actually prefer is Chainlit. So Chainlit comes ready-made as a chat application. All you have to do is integrate it into your LLM-powered application, and you're ready to go. So what I like about Chainlit is it works really well with all of the frameworks, including Llama Index, Haystack, AutoGen, and LangChain. It's really easy to build, and I think it's even easier than Streamlit. So if you're not familiar, please check out Chainlit. You should see on screen now an example of an app that I've developed in Chainlit. The course I have created for you also has the front end developed in Chainlit, so you can get to grips with that if you want to get your hands dirty. But that is pretty much it for the large language model ecosystem. I hope that this video has managed to tie everything together for you. Remember, there is a technical article available, so if you need to revisit any of the concepts, it will be in the technical article, or you can simply rewatch the video. If you find this content useful, it would be really helpful for the channel to subscribe to the channel, like, comment, or share this video. This has been lecture 2 of the AI Engineering Takeoff course. I hope you've enjoyed the lecture, and stay tuned for more lectures.